So far, we've seen that if you want to integrate something along the line of this, you have to somehow break this up into something along the line of this. And in the past, we've always required that Q of x must have distinct linear factors, meaning all these factors here have to be distinct. They all have to be different. Okay, so now we're going to look at a case where we are going to have repeated linear factors. So we are now going to look at a case where Q of x has repeated linear factors. So if you look at this here, if you zoom into this bit here, so here you've got a repeated linear factor here. This is to the power of 2. So you've got a repeated linear factor. Well, in a case of it being repeated, you have to rewrite this in the form of 1 fraction plus, now so here you've got your repeated here, and then in the next fraction you have to have this squared here. Okay, and then you've got this fraction here for this factor here. So when you get something in the form of where you have repeated linear factors, where this thing here is repeated here, you have to break this up into 1 fraction where this is your repeated fraction, repeated factor here, and then in your second fraction you have to have this squared. Now the hard part is in understanding why is it that you have to have this squared here. So you've got to repeat it here, and then here you've got another repeated, but then you've got to square it. It's hard to understand why we have to square it. So now let's look at the case where you don't square this. Okay, so by right, when you get something along the line of this, you have to break it up as 1 fraction plus another fraction plus this fraction here. By right, you should do this. But now let's look at the case where we're going to attempt to try and do it without the squared here. So now let's try. So this is the wrong way of doing it. So now we're going to try and break this up into 1 fraction, and then plus another fraction without the squared here, and then plus another fraction. This, by the way, is the wrong way of doing it. So if you try and do it this way here, looking at this here, we want to try and we want to try and work out C first. So we would times everything by this bubble here. So looking at this, times everything by x plus 2. So this thing times by x plus 2, and then this thing here times by x plus 2, and then this thing here times by x plus 2, and this thing here times by x plus 2. Now these two will cancel out, giving you this. This thing here will become this, and then this thing here will become this, and then this thing here. Remember, when you times by x plus 2, this thing goes, and then this thing goes. So this is this, and this here is this. So here we can work out C, because by the time we get to this stage here, we can say let x equals -2. Then if we let x equals -2, then this thing here will be 0. That meaning that the whole thing here will be 0. The whole thing here will be 0, and it will give us C, which is good. But the problem arises when you try and work out these two, because okay, let's start from here. Now from here we can work out C. That's good. We can work out C. But then when it comes to multiplying everything by, let's say, x minus 1. So here you times by x minus 1, 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 then this thing will become this. This thing here will become B. This thing here will become A, and then this thing here will become this. And then by the time you get to this stage here, you would say, oh, let x equals positive 1. So this thing disappears, and now you've got A and B. So it's not really it's not really useful. So this is the wrong way of doing it. But if you look at the right way of doing it, so now we've got one block, and then we've got this thing squared. Now if you times everything by, so now looking at this here, let's times everything by this block here. So x minus 1 squared. If you times everything by x minus 1 squared by this block here, then this thing here will become this. Okay, and then well, when you get to this stage here, you can you can let hang on, let me think. You can let x, yeah, you can let x you can let x equals let x equals positive 1. So if you let x equals positive 1, then this thing here disappears, and then this thing here will disappear, so leaving you b, and then because you've got this being different from this, in the second case we would say, now so up here we would times everything by this. Now in this case here we're going to times everything by this. So down here we would times everything by x minus 1. Well, hang on, let's look at this thing here. Times everything by x minus 1. That will then give you this. So now this thing here actually serves a purpose. I will continue in the next video. But the point is that these two have to be different. But by you getting to this stage here, by the time you get to this stage here, we would have worked out. I will continue in the next video. Okay, but by right, make sure that this is different from this, because it will help us. If these two are the same, it serves no purpose. If these two are the same, you will get to this stage here where you've got two unknowns. Whereas if you make one to be squared, then it does actually help you. I will illustrate that hopefully in the next video.